Hello ladies and gentlemen, welcome to another edition of Let's Code. We are going to be coding a linked list today in Java, and not only the linked list, we're going to be implementing a stack with a singly linked list today. So if you're not that familiar with what a linked list is, please do some research ahead of time. I'm going to assume you're pretty comfortable with the concept of a linked list. And at this point, you're really just looking to see what the code looks like and maybe code it up yourself in Java. So with that being said, let's go ahead and switch over to IntelliJ where we can get started. So what we're going to do first is we're going to create a new package for our linked list. And inside that package, we're going to create a new node class. So our node class is pretty straightforward. It's going to have a integer value to represent the value, and it's also going to have a next pointer, which is another instance of the node. So let's just create our getters and setters, and I'm using a lot of hotkeys here with IntelliJ. You can look those up if you're using IntelliJ, but it is a sign of a professional when they take the time to learn their hotkeys and become more efficient with their IDE of choice. So we've got our node class here. It's got an integer value. It's got a next node pointer, which having a node inside of a node is an example of a composite class. It's a composite data structure. So if you're interested in design patterns, take a look at those, and it comes in handy in a lot of places. So once again, here's our node. Now we want to create our linked list class. And we're going to call this a linked list stack, since we're specifically doing a stack implementation of a linked list. So what we're going to be doing here today is we're going to create a private node top. So this is going to represent the top node of our stack. Okay, and then we're going to be, let's get my little book here. We're going to also keep track of the size. So what we want to do is have a private int size. Okay, so those are the two values that we want to keep track of with our linked stack. So let's go ahead and implement our size method, and it's going to return the value of size. Let's implement our isEmpty method, and it's going to return if size is 0. Let's go ahead and implement our method that's going to return us the top object, and that object is going to be a node. So what we want to do here is first we want to check if it's empty. And if it's empty, I'm going to return null. You could return an exception here. You can do a lot of fancy things. But for example's sake, we're just going to return null. And let's just go ahead and print out stack is empty. Okay. So now, otherwise, we want to return top. And let's go ahead and also create our constructor here, where we can initialize our variables to top is null, top equals null, and size equals 0. So when a new linked list stack is instantiated, we'll set the top value to null, and we'll set the size equal to 0. There's not currently any objects in our stack. So that's what our top method will do here. Now we want to implement a push method, which is a standard interface method for a stack. We want to be able to push elements on, and the element we're going to be pushing on is a node. And so you can do this one of two ways. You can push an integer and then create the node out of that, or you can push a straight node. Let's push an integer. So in order to push an integer, we're going to make this node class a bit more efficient and create a constructor that takes in the integer. and sets this dot value equal to I. We'll also create a no argument constructor just in case we want to create a node without passing in an integer there. So here's our push method. We're going to say node v equals new node I. So now we have a new node that has the integer value there. We're going to set top equal to v, and then we're going to increase our size. Okay, so now we've pushed a new node into the stack. So what we also want to do is we want to basically set the next value. So the next value in a stack for this node is going to be the previous top. So let's actually go ahead and update our node constructor and pass in node in and set this dot next equals n. So this will allow us to actually set the next pointer of this node at the time we create it, and we should be able to pass in the current top value. So now I've created a new node. It gets instantiated with the value I and is pointing to top. So if you can imagine that in your head, we're just adding nodes on the stack, and each time their next pointer is getting updated to what was previously on the top of the stack. Okay, so that should take care of that. And then we have our pop method, which is going to return the top object on the node, on the stack. So what we want to first do is check is empty. If it's empty, we're going to return null. We'll also go ahead and do a little output here to say stack is empty. Else what we're going to do is get the current top value. We're going to set top equal to top's next. We're going to decrement size by 1. And we're going to return old. Okay. Top is already defined in the data structure. So, I'm sorry, this method is actually named pop, not top. So we want to pop the top object off of the stack. So once again, what we're going to do here is we're going to check to see if it's empty. If it's empty, we return null. If it's not, we're going to get the current top value. We're going to set the top value to the next value of the top value and then return the old value. So we're basically just going to pop that guy right off the list and return that object. So that should take care of our linked list stack implementation. Pretty straightforward. The interesting piece is the way that we create our nodes by passing in an integer and the next node. It makes it really simple when we go to push a new object on. We can just pass the current top and then increment our size. So let's create a couple of tests in our main method. Let's instantiate our linked list stack. Okay. And let's go ahead and push new integer 5, new integer 1. Let's push 1 first, and then we'll push 2, just to keep it simple there. And let's print top. Once again, for IntelliJ, you can type S out, and it'll give you different options to actually do template. So you don't have to type system.out.println every time. And we basically want to print stack.top. So now if we run this guy, we should see 2 printed out. Since 2 is the value on the top. And in order to make that work, I need to call the method, not the member. So it printed us out a memory address of the member top. Okay. Let me see what's going on here. Stack dot top dot get value. Right. It's a node. So in order to get the value representing the node, we have to call the get method, and there we have our 2. So that's fantastic. So let's go ahead and do a stack.pop. Okay. And then we'll print the top value once again. And after we pop, the 2 should come off. We should be left with a 1. So there we have it. 1 is printed. Let's do this one more time and see what we get. I'm suspecting that we're going to get null value printed. Yeah. So as you can see, we popped off both values, and then we still tried to call a pop, and we also tried to print when there was nothing in it. So we printed out the stack is empty, and we threw this main exception here, null pointer exception. So that's pretty much it. That is the linked list implementation. Important to know, singly linked list has a node class which represents each item in the list, and those nodes have pointers to their next objects. So you can just update those pointers and you change the complete order of that list, which makes it very efficient and very easy to use. So I hope you guys enjoyed this version of Let's Code. I really thank you guys for watching, and remember, if you're interested in blogs and you want to sort of grow professionally, go to mindfulbit.com, check it out. I have a blog and a coaching service where I really help entry-level professionals grow their career, sort of teach you and coach you some of the soft skills required to get to the next level, and some of the nuances that come with being a software developer. So it's one thing to know the code, it's another thing to know how to work with your coworkers, how to communicate efficiently, how to set boundaries, how to protect yourself against burnout, and all these other things that become really important as you grow and advance your career. So once again, thanks for watching, and I will see you on the next video. Bye-bye.